Hi there, this is Kenneth Wong, Senior Editor for DE 24/7, reporting from NVIDIA GTC in San Jose, California. Humanoid robots, software that you can talk to in natural language, and digital twins are on the rise. Powered largely by AI, the primary business of NVIDIA for the foreseeable future. You might say OpenAI's ChatGPT broke the dam on natural language processing, unleashing a flood of new applications. This is NVIDIA's XR booth, showcasing the digital twin of a BAC Mono sports car in mixed reality, rendered in Autodesk VRED. Guess what? You can talk to the application, and here is a preview.
Change the rear to red.
Rear red.
Remember the current color configuration as American flag.
Preference remembered. Current and configuration. Please specify the details if you need a specific attribute remembered.
One of the things we found when we have situations like this, when we want to visualize an XR, is it's quite difficult to interact with the model in XR for many people. It actually requires some training and some experience to learn how to use hand controllers, to manipulate menu systems, and to do all the technical things that are involved with making changes in a design application like VRED. So what we wanted to do was create a simple user experience that's based in sort of natural human language. We want people to just be able to talk to the application and tell it what to do. All we did was create the commands in the application that do things like change paint color, and we made the list of available paint colors. It's a feature called variant sets in VRED, but many applications have similar functionality where you have sort of a top level menu name and you have a list of features under that menu. And so we're essentially just reading that list of commands from the application. So the software we have goes into the application through its API, reads the list of available commands, and learns them. It now knows how to do those things. It can execute those commands. And so now if I give it a command like change paint color to red, it recognizes the command change paint color, and it recognizes the color red from the list of available colors, and it goes and executes the right commands to make that happen. So we're really counting on the intelligence of the large language model to do most of the work for us. We're not actually doing any training per se, other than creating a list of commands in the application.
There is also an application that uses simple 2D images and convert them into holographic models. The program is AI trained using a large collection of high-quality 2D images, not even 3D data, but somehow it's able to understand dimensions and depth of field to recreate them from 2D input. Here's a snapshot of myself, the one on the left, as a holographic avatar. Usually at the heart of these applications are algorithms derived from machine learning. With the release of a new GPU called Blackwell, machine learning will likely get faster and more powerful. This will have an impact on the speed of engineering simulation.
Sure. So, I mean, when you see an exciting new piece of hardware like that, really all it comes down to is the ability to crunch numbers very quickly, right? If you think about what Jensen was talking about, he referred to floating point operations per second, flops, right? And for the past decades in CFD and in HPC in general, we're always tracking what's the maximum number of floating point operations per second that any computing system can reach, right? And so ultimately all it's about is pushing that flops higher and higher and higher. And in the past couple of decades, we've relied on Moore's law for that to happen. And Moore's law in the CPU context is essentially dead. And now pushing the horizons of HPC looks like GPUs, right? And so ultimately, the amount of numbers that you can crunch, that's what's going to dictate how quickly you can turn around a CFD simulation. So a new system like Blackwell, I mean, there's way too many factors for me to be able to say, oh, well, if we're seeing X performance on an H100, this is what we'll see on Blackwell. I don't know, we have to run it and test it. But it's going to be impressive because the flops of Blackwell is far exceeds anything that exists today. Yeah. AI provides us an opportunity to take pre-existing data and basically reuse it, make use of it, create neural networks from it that allow us to deploy that AI trained model on new designs in the future. So AI, when it comes to CFD, is very much a complementary technique that allows CFD engineers to explore entirely new designs and explore entirely new horizons, right? And free up their time from running simulations that are really, they don't need to be running because they've run sufficiently similar types of geometries and designs in the past.
Blackwell targets the server and data center market, the high-performance computing space that's always hungry for more data, more processing power. For engineers, that workflow probably begins at the workstation and then move to that next phase.
Yeah, I mean, what Blackwell does is enable incredible scale, but where does that scale start? In HP's mind, that starts locally with our solutions of workstations and our AI Studio software product, where initially, before you're developing your model on these big data sets, you're going to want to be developing these models locally on smaller data sets, fine-tuning, prototyping, getting your parameters correct before you scale out on the expensive Blackwell solutions. Yeah, one of the biggest things we're trying to do is centralize not only customers' data, but the collaboration and the compute. We're really focused on enable seamless transitions of workflows between those local devices and then these cloud and data center devices as well. So portability is a big part of our value proposition and simplifying those workflows to make it easier for anyone to develop these type of data science and AI models that are becoming much more popular and much more critical for everyday workflows.
During GTC, Siemens announced its partnership with NVIDIA to integrate NVIDIA Omniverse APIs with its accelerator portfolio.
Siemens technologies transform the everyday for everyone. Teamcenter X, our leading product lifecycle management software from the Siemens Accelerator platform, is used every day by our customers to develop and deliver products at scale. Now we are bringing the real and the digital worlds even closer by integrating NVIDIA AI and Omniverse technologies into Teamcenter X. Omniverse APIs enable data interoperability and physics-based rendering to industrial-scale design and manufacturing projects. Our customers, HD Hyundai, market leader in sustainable ship manufacturing, builds ammonia and hydrogen-powered ships, often comprising over 7 million discrete parts. With Omniverse APIs, Teamcenter X lets companies like HD Hyundai unify and visualize these massive engineering datasets interactively and integrate generative AI to generate 3D objects or HDRI backgrounds to see their projects in context. The result? An ultra-intuitive photoreal, physics-based digital twin that eliminates waste and errors, delivering huge savings in cost and time.
Like Omniverse APIs, NVIDIA is also offering what is called NIMS. It stands for NVIDIA Inferencing Microservices, and that's for application developers, so we can expect other partners to develop applications built on top of them. For more design and engineering related news, please go to DE247. That's digitalengineering247.com. Now I'm going to leave you with more footage, more glimpses of new technologies from GTC 2024. Bye for now.
Want to move the robot, of course, but how can we design a robot that could be so easily moved without that threat? No? Want to dance?
Making delicious drinks with unmatched precision. And thanks to NVIDIA, I can even talk to my customers.